Welcome, ladies and gentlemen, to this video lecture. Okay, let's take a look at this example. So we want to compute the following integral. And we see here we've got the product of two functions. Okay, so let us try to use integration by parts to compute this integral. Okay, let's see what will happen. Let's take a look at this part. The cosine is a derivative of sine, and remember how does integration by parts work? We can pass one of the derivatives to the other function, and then we see nothing changes, or there's only a constant that comes up. So the derivative of e to the 2x is 2 times e to the 2x. So by passing a derivative to the other function, this other function is not going to change very much, or let's say will only change up to a constant. And if we pass a derivative from this function to the other function, it's going to change to a sine. Okay, but then we've got for example, we've got something that looks like this. Okay. And then what we see here is if we again pass a derivative to the e to the x, what we will end up with is something with a cosine, and this is the same as that. And then what we will do is we will relate our result to this symbol that we have defined, I. So that is the idea. Okay, let's follow through on that. Okay, so let us we are going to call this g prime and that f, and we're going to pass the derivative to g prime. So let f of x be defined as e to the 2x, and g prime of x be defined as the cosine of x. Then we've got f prime of x is equal to 2e to the 2x, and g of x is equal to that is going to be sine of x. Good. Okay, then using integration by parts, we see that our integral I is equal to integral from 0 to pi over 2 of f of x, g prime of x dx. That is the same as the integral from 0 to pi over 2. Oops, no, that's not what I meant. F of x, g of x, evaluated between 0 and pi over 2, minus integral from 0 to pi over 2 of now f prime of x, g of x dx. Okay, let us substitute back in. This is e to the 2x sine x, evaluated between 0 and pi over 2, minus 0 to pi over 2. Derivative of f is 2e to the 2x multiplied with sine x dx. Okay, so that part is easy to evaluate. We are left with this part, and what we will do is we will apply integration by parts again to this part. So let's see, let's set u of x as what are we going to set it as? E to the 2x, and then its derivative is 2e to the 2x, and v prime of x, we're going to set that as sine x, and v of x then becomes minus cosine x. The derivative of cosine is minus sine, so if we set v equal to minus cosine of x, then its derivative is equal to sine of x. Then we see, if we look at now this integral that we have here, I'm going to take this constant 2 out. So this integral 0 to pi over 2 of e to the 2x sine x, that is equal to 2 times integral from 0 to pi over 2 of ux v prime x dx, and this is equal to 2 times what is that, ux vx between 0 and pi over 2 minus integral from 0 to pi over 2 u prime x vx dx. And if we now plug in our values, this is 2 times, and this is minus e to the 2x cosine x evaluated between 0 and pi over 2 minus, and this is 0 to pi over 2 of 2e to the 2x times cosine x dx. Okay, and what you should notice here is this part is related, or looks suspiciously similar to our original integral. There's only a constant 2 factor difference here. So this I is the same as that, except for this factor 2. So if we compute what this is, so this is 2 times, and now if we plug in everything that we get here, substitute in our values, we get this turns out to be 1 plus, and now I'm slightly confused. This Vx is a minus cosine x, so in fact here that turns into a plus. So sorry about that. So notice here this Vx is a minus cosine x, so we end up with a plus there. Okay, and then we see here this is, if we take this 2 out, this is 2 times I, where what is this I? This I is our original integral that we had. Okay, so now we know, remember our original integral that we had here, I is equal to this minus that, but we have now computed this term in terms of I. So I is equal to e to the 2x sine x 0 between 0 and pi over 2, that is this term, and minus this term, which we have computed here in terms of I, and that is, if we just plug that in there, 2, 1 plus 2i. Okay. And now, if we evaluate at 0 and 2 pi and minus 0, what we get e to the pi minus 2, and if we simplify a little bit, we get minus 4i over here. And now all we do is we solve for I. So we've got this equation, we solve for I. So we know I is equal to e to the pi minus 2 minus 4i minus 4i, and we solve for I, so I is e to the pi minus 2 over 5. Okay. And that is it for this example. So what was the main feature here in this example? We saw here that we could, by applying integration by parts twice, we could set up an equation involving I. And finally, we then solve for I in that equation, and that gives us then the value of the integral that we are looking for. Okay, I will see you in the next one.